basically, yeah, I was trying to download one file from somewhere and store it in the Drive, Google
Okay.
thing. Okay.
Okay.
Now, in this Colab, it says like it's.
It
I'm
it
not
it will be giving
able
you a
to.
warning.
No, it's not warning. I it got all the folder from Drive. I don't want to get all those, right? So in
Okay.
this case, I'm trying to delete the Google Drive. It seems it's not allowing.
Um, so what you have to do is
Mm-hmm.
you have to basically wait, huh? Here you will see an let's suppose create a new notebook.
Mm-hmm.
So what you have to do is you have to click on this folder, right? You have
Yes, yeah,
probably clicked, okay.
yeah.
So it
Mm-hmm.
will take us some
Mm-hmm.
time for connecting to runtime.
Something.
So what you have to
Mm-hmm.
do is you have to click here like no file
Mm-hmm.
selected, right? So when you
Mm-hmm.
click or you have an option that you can upload from drive. You can
Mm-hmm.
either mount your drive, so it will
Mm-hmm.
take all the Google Drive files. We don't want this thing, okay. Like
Yes,
it will ask
yes.
you that you want to connect it to Google Drive. Probably you have done this
I
option.
clicked that one.
Yes,
Yeah.
so you don't have to do
Okay.
this. What you
Mm-hmm.
have to do is you have to take your from your local
Fine. Okay.
storage. So if you click on
Okay.
this, it will ask you the
Mm-hmm.
local storage, like
Yeah,
on my
that one I aware of. Yeah,
yes.
correct.
So you
But
can
the thing is,
yes.
now I want to delete the Google Drive. It's not allowing me to delete. That is the issue.
Okay, means like you have connected this thing, right?
Yeah, yeah.
So one simple, very simple way of doing it, you can
Uh,
create a new notebook. Can you do that?
what do you want me to do there?
You can create a new notebook. Simply, you can just delete this notebook that you have created.
No, even I tried that another new notebook. Still, that Google Drive is there.
Okay. Um.
It says like we can't delete Google Drive.
Oh. So.
It shows all the file, whatever in this one. I don't know. Yeah. Mm.
So the means you can every time you reload it, even then, right? I think once you disconnect it from your server,
Mm.
though those all files will be vanished. I think means because it is on your runtime.
Yeah, you are right. See, in this case, if I get file from local, so
Okay,
it's
okay,
got
okay,
vanished.
okay, 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 okay,
Okay. So,
okay, okay.
but the thing is, I want to delete the Google Drive. It shows all the file, whatever I have in the Google Drive, photos, everything. I don't want to see it. Okay. Yeah, this is the issue I'm facing. But other than that, I'm working on this. So, yesterday I
So
was trying to make a.
are you getting something like this, right? Drive and
Yes, yes.
inside
I
this.
want to, yeah, I want to delete the drive. Can you delete the drive? Yeah.
Okay, can you can do this? You
Yes.
are getting
Yeah,
this
I tried
option.
that. Yeah. Click. Yeah.
Yes.
Yes. Okay.
My
But
drive is
it's
not
not. See?
empty. Okay, only empty
That is
directories
it.
can be deleted.
Yep. Mm-hmm.
Right. Okay, I will also
So,
find the option means like
sure.
how I can do this because I have
Mm-hmm.
never used like uh, this mounting the Google
Yeah.
Drive. If I found the
Oh,
solution to it, I will let you know. Okay, onwards on wherever I
sure.
found your contact. Okay.
Yeah. Yeah. Sure.
Okay.
Sure.
Yeah.
Thanks, Imaj. Yeah.
Yeah.
We can
You may
proceed.
continue
Yeah.
what
Sorry
you
about.
are saying. So you have gone
Mm.
through the other files, right? Means like the other
Ye-
thing that we discussed on the class. Did you have
Yes.
gone through
Yeah.
that? Was
Yes.
everything working? Yeah.
Yeah, I'm trying to do that. I'm okay with all those whatever we have. I'm trying the couple of new things as well, but I'm not yet try
Yeah,
this
yeah,
one.
no
What is
problem.
that
Whenever you
multi
get,
one?
yeah, no problem. Whenever
Yeah.
you get time, you may go
Mm-hmm.
through it. It is not
Sure.
necessary that you may go. Just you are getting the idea, and you may try and use some other code as well and try to understand that.
Yeah, yeah. I'm doing that one
Yeah,
as well.
yeah, yeah.
I'm yeah reading some documentation and yeah, I'm
So
trying
that
to
is the
get all
best way.
those
Yeah,
functions.
yeah, yeah.
Yeah.
So that will be
Mm-hmm.
the best way of learning thing. Like you can read the
Mm-hmm.
documentation. It is the first
Sure.
hand information or knowledge that you get. Okay.
Yeah, and one more thing. Yeah,
Yeah.
one quick question. Okay. So here, print.df means what is the difference between print and yeah, df dot shape is there, right? Can you down? Yeah. Can you here if you write the code one more thing print.df I mean print yeah, what is the difference?
Print and df
Print
this.
of yeah df dot yeah df dot
Okay, okay,
shape
okay.
or df
Let's first uh,
correct?
can upload the files.
I don't see any difference in the output. I just wanted to make sure both are same or there is a difference between a df dot shape and a print d- um, df dot shape. I want to see the difference.
Okay. So we have this. The data set is same.
Mm-hmm. No.
Okay. So this print function, what it will do, it will
Yeah. Pr-
print your data
Print
frame,
dot
display your
shape.
data frame.
Yeah, that one will display the data frame,
Hmm.
but df dot shape
So
print.
okay, so
Yeah.
print this
Yes.
thing.
Yeah. I want. Mm-hmm.
I think it should be
Same
the
thing, right?
yes. Yes, so
Okay.
see
I
what,
just.
yeah. So the
Mm-hmm.
difference in this while you are using this notebook, it happens
Mm-hmm.
only in this like notebook thing, like in Google Colab or in Jupyter Notebook. If you write this same code in Visual Studio Code, like any other IDE that runs on your local host, local computer, so
Mm-hmm.
then whenever you want to display anything, right? You want to display anything,
Mm.
you have to write this print statement. This thing only works in Google Colab or in
Oh,
Jupyter Notebook, that without even writing your print statement, if
print
you run this,
statement.
it will work fine. It will show you the statement.
Oh,
But the issue
okay.
here is that it will just
Mm-hmm.
display the last line. Like if I will write here,
Mm-hmm.
suppose say df dot head. Okay. So now
Mm-hmm.
if you will see, it will not give me this output. If I will run this,
Oh, okay. There's a last one. Oh, okay.
only this
Oh,
last
oh,
line will be executed, means displayed. If you want to
okay.
show this,
Got
then for
it.
sure
Print.
you have to use this print statement.
Okay. Got it. So basically, without print statement, it displays on the last data frame.
Exactly, exactly. So and
Okay.
this thing
Gotcha.
only works in this notebook thing, like on Google Colab or
Yeah.
in Jupyter
Oh,
Notebook.
okay.
That
Gotcha.
without print also you can display your
Mm-hmm.
output.
Okay. Yeah.
Okay.
Thank you,
So
Sutran. Yeah. Please
yeah.
go ahead.
Okay. So it is the best practice if you use this print statement.
Mm-hmm.
Okay. So this is like a very
Okay.
shorthand or easy to use, but it is a best practice if you write this completely.
Okay. Gotcha.
Okay.
Mm-hmm.
So on the last session we dealt with univariate analysis, right? Like
Yes.
here
Correct.
we see some numerical data and we have a categorical data, right? We have
Yes.
distinguished
Mm-hmm.
between them. We have saw the what
Okay.
is the difference between numerical data
Mm-hmm.
and our categorical data, and we have seen some different techniques and some different graphs for each of them. Like the graphs and the techniques that were used for numerical data was different from our categorical data, right? If you see
Mm-hmm.
graphs for this categorical data like S or C or Q, these are basically not numbers. Okay, so they are
Yes.
categories,
Okay. Okay.
and this male and female, this are categories. Okay, so this is a categorical
Mm-hmm.
data, and the graphs or the technique that we use are different. Okay, and this is a
Mm-hmm.
numerical data, so we can perform some computation here as well for this
Okay.
numerical type data like age.
Mm-hmm.
So we can draw some histograms and we can specify bins. Okay,
Mm-hmm. Mm-hmm.
and similarly like for other plots as well. Okay, and at the
Yeah.
last we saw a pandas profiling tool. Okay, so that
Yes.
basically sums up all the um, and data analysis, like basic data analysis that you want to
Mm-hmm.
see. Okay, so in today's session, what we will do is we will deal with a concept that is bivariate analysis.
Mm.
Bivariate analysis. And if we get some time at the end, then we will be try to see a technique that is scaling.
Mm.
And scaling means like basically you have a data, and we will see
Mm-hmm.
what it is, okay. And we
Yeah.
have will have an encoding method, okay.
Mm.
Encoding method. I have given you a just brief about how encoding works on our previous session, like we were having male and female. So if you want to convert this category into numerical data, so we will use
Mm.
an encoding technique
Zero.
to convert
Mm-hmm.
them like in 0 or 1, okay. So all
Yeah.
the data
Mm.
will be encoded with 0 or 1, okay. So we will see
Okay.
how it
Mm.
works on Python code, okay. So like how you can
Mm.
convert all the code in like 0 or 1 for male, female, or anything like for embarked. Or here we were having a
Mm.
category that was named embarked
Mm-hmm.
SCQ. So how we can
Mm-hmm.
convert them to numerical? So we will be using an encoding method, okay.
Mm. Mm.
So let's start with this bivariate analysis, okay. So what we do in bivariate analysis is we take two variables, okay, or you may
Mm.
say two columns, okay. So
Mm.
to have a data set mm, 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 mm. Okay, so this was our data set. So in last video we see how we can deal with a single column, right? So in today
Mm.
we will see how we can deal with multiple column, like age. Suppose you want to
Mm.
see some relationship between age or sibling spouse, like is there
Mm.
any relation? There might
Mm-hmm.
not be, okay. But if you will
Mm.
see relation between fare and your passenger class, right? So there would be a huge relation,
Yes. Mm-hmm.
okay, because passenger class may be directly dependent on your fare. If a
Yeah.
passenger is in a higher class seat, so definitely the fare for this person will be increased, okay. So if you see that
Mm.
if the person is in a class 3, he have a pretty uh, mm, lower fare. But when a passenger gets increasing with the passenger class a certain level like a 2, so you see
Mm.
the fare also increases like 29. Until now
Mm-hmm.
it was
Yeah.
like 7, 9, 8, 12, 9, 7,
Right.
because the passenger
Mm-hmm.
class was
Mm-hmm.
3.
Mm.
When we go to 2, the passenger class suddenly increase with 29, okay. So such thing we deal with in our data, because see this thing we can't do like manually for all the columns, right?
Correct.
So we will
Mm.
try to do some coding, or we'll try to do some analysis with it, okay.
Mm.
So we will take this same data, and not actually the same data, we will be using a different data for it, okay. So let me
Mm.
bring the code to you. So the library that we will be using will be like same, the pandas, okay. So
Mm.
as we have seen on the previous code for our can you tell me for which purpose is pandas used? Like you can do some guesswork, means for like what kind of thing, for which purpose you think like pandas will be used, mainly used. Like here we are using for reading the CSV file, reading the data.
Mhm.
And
Mhm.
so can you tell me like overall means for which purpose this, like
I'm going.
uh,
I
because see, yeah, yeah,
so
no problem,
yeah.
it's fine. See, because basically for dealing with the data, right, we use this
Mm-hmm.
pandas here, PD.
Mm-hmm.
And now everything we do is will be on Titanic, right? Every time you see
Mm-hmm.
here we are doing is will be with Titanic, like here Titanic, okay, Titanic dot head. So what it, and if you see that Titanic is what it is basically your pandas, PD.
Mm-hmm. Mm-hmm.
So it basically helps you to overall guide your data, like, or you can say data manipulation.
Manipulation. Yeah, that's what I'm. Yeah,
Yes.
like easily to
You may like try to remember because it will come again and again, so it is means handy to convey.
remember all the.
Yes.
Sure.
And
Mm.
one more thing, like you have another library that you will see more often, like that is NumPy, and it is
Number.
for
Very
data
numerical
calculation.
calculation. Yeah.
Data manipulation, for manipulation you have pandas, for calculation you have NumPy. Okay.
Okay.
And for
Mm-hmm.
visualization you have Seaborn and Matplotlib.
Yeah.
Okay.
Mm-hmm.
Now here what we are doing is we are loading our dataset, that is tips. Okay. So inside this
Mm-hmm.
Seaborn library there is a dataset that is your tips. Okay.
Mm-hmm.
So basically we are loading that dataset. Okay. And
Mm-hmm.
storing that in our tips. If you see
Okay.
earlier, uh, we were taking the dataset from our local storage, or we were having that. If you see here, we are taking the
Okay.
CSV file from our local server or local host
Mm-hmm.
or your local storage, right? But
Mm-hmm.
now what we are doing is we are using a library that is sorry, we are using a dataset that is inside this library itself. Okay, you
Okay.
see this, we are using here
Mm-hmm.
SNS.
Mm-hmm.
So what this SNS specifies is it is your Seaborn library. Okay.
Okay.
So what
Mm-hmm.
library is? Basic library is a set of pre-written code. Okay. Are you comfortable with
Cool.
this?
Yeah.
Means like you are, I think, means because, right? I think it should be clear, like what a library is, right? If any time and at any point you have any confusion, let me know.
Yeah.
Okay, because
Library.
I am expecting a few, means like you, if you means whenever you have some doubts at any point, you may let me know. Okay, so that I may
Sure. Sure.
skip some basic points. So in
Sure.
this library you have a function that is your load underscore dataset. So
Mm-hmm.
what this load underscore dataset, it takes your dataset name as an argument. Okay,
Oh.
like it has
Okay.
some
Mm.
more dataset, so you have to tell which dataset you want. Okay, so for
Mm-hmm.
this example or for this code we are taking this tips dataset. Okay, so this dataset
Mm-hmm.
contains basically your tip, a person, and the restaurant or a
Mm-hmm.
bill. You may say think of it as a restaurant. Okay, so a person came in a restaurant,
Yeah.
and this is the
Mm-hmm.
gender of that person, and is
Mm-hmm.
that person a smoker or not. So the data about that person is given here. Okay, at which time
Mm-hmm.
the person came for the on the restaurant, like on day
Mm-hmm.
was a Sunday, right? And
Mm-hmm.
which time, like dinner. Okay, and size,
Mm-hmm.
maybe I think size is the how many number of people. Okay,
Yeah.
and at finally you have your total bill.
Mm-hmm.
Okay, and on
Mm-hmm.
based on this information we have to try to predict, our machine learning model is have to try to predict, for example, what could be the tip that this person can give.
Okay. Mm.
Like if a
Like it's
person is,
2%. Mm-hmm.
yes, if a person is male, if he is
Mm-hmm.
not a smoker, and
Mm-hmm.
if he came on Sunday and the timing
Mm-hmm.
was dinner and three people
Mm-hmm.
came in and the total bill amount was $10, 10.3534. Okay, so
Mm-hmm.
what amount can this person may be likely giving the tip?
Mm-hmm.
A machine learning model may predict like 1.34, 1.24, 1.98. Okay, so that will be a
Mm-hmm.
predicted value. Okay, if you see what
Mm-hmm.
in machine learning we call, we say it as a predicted value. Predicted value, the value which our machine learning model give to us. Okay, like I will be providing the data to our machine learning model. Suppose say this is our ML model. Okay, so what it contains, it contains basically your algorithms. Okay, so
Mm-hmm.
algorithms like linear regression, so it is just a name of your algorithm, linear regression. Okay,
Mm-hmm.
so it contains your algorithm linear regression, and it contains some techniques like your this scaling, encoding, and these techniques. Okay,
Mm.
so it does all those processing. Okay, so what you will do
Okay.
is you will pass your data. Okay,
Mm.
and you will divide your data in two set. So this is the important thing. Okay, try to understand it. At the starting of your data set, you are having a data set, you have some features. In machine learning term, we say these columns as features. Okay, so this
Mhm.
is your column. As a machine learning term, we say it as a feature.
Yeah. Mm.
If you read any blog or article, you will be seeing feature. Okay, not a variable or not a column. Okay, so we say as a
Mm.
feature. And
Mhm.
you have, suppose, say in this example, 1 2 3 4 5 6 features. Okay, we have six
Mhm.
features in this example, and this is your target value. Okay, so this is your target.
7 features.
Yeah.
7 features, right? One, two,
No,
three,
no,
four,
no, no.
five, six.
So seven feature, you can say this as a feature also, but actually this is your target value. Okay, so according to, based on these features,
Mhm.
this means this six, you will try to
Mhm.
predict this value, this column.
Oh, okay. Last one. Gotcha.
Yes.
Mm.
Okay, so
Mm.
it is called as a target value, or it will be
Mm.
called as your uh, dependent variable,
Okay. Mhm.
and these are your independent variable. Okay,
Mm.
independent. Okay,
Mhm.
so in our this example, suppose for an example, we can take, it is not any rule that your tip should be your only your dependent your target value. Your total bill can
Mhm.
also be, but it just depend on your what your you want the out from your machine learning model. Okay, so suppose say
Mm.
in our example we want to predict what will be the tip.
Mhm.
So this total bill, say TB, gender say sex, and smoker, say smoker S, day time size. Okay, day time size. Okay, so
Mm.
this will be your independent variable. So their value can be anything, like ranging from these values. Okay, and we'll try to
Mm.
predict this thing, like what is the tip. Okay, so we
Mm.
give this data to our model. Okay, we will specify that these are the features and this is the
Mhm.
target value. Okay, and
Mm.
one more thing we will do here is we will cut off our data, and this ratio can be anything, depending on your requirements. Like most of the time it is 30 70 30 ratio. Okay,
Mm.
70 30% for above and 30% below. Okay, so we will
Mm.
cut off our data set. This was our original data set. Okay,
Mm.
so what could be the possible reason for doing this step? Like, because we are giving the data to our machine learning model, and machine learning model will predict something, right?
Mm.
So now we need something to compare this prediction, how accurate our prediction is, right?
Mhm.
Because it is of no use that it predicts anything and we say it is good. So we need any
Yeah.
metrics, or say, we need anything to compare compare
Mhm.
the accuracy,
Mhm.
like what percent of the predicted value are correct from the output value, right?
Mhm.
and and for doing this step we need data to train our model. Okay, so what we will be doing in while machine learning modeling is we will be feeding the data to it. Okay, so we will say, suppose, total bill. Okay, for
Mm.
first iteration we will say
Mhm.
if the total bill is 16.99, and gender, sex is female, smoker is no, day is this, the tip is
1 5.
1.01. Okay,
Mm. Mm.
and for the same thing, like for this iteration total bill is 10.99, 34. The total bill is, and the tip is 1.66. Okay. So now what here a model is doing is it is seeing all the data. Okay.
Mm.
So the problem here is if it see all the data,
Mm.
and but at the end of this it will have, it have seen all the data. Okay. So while trying to predict the accuracy, it will get some issues. Okay. What they will be like, I'm actually I have confused you, I think.
No, no, go ahead. Yeah.
Because like most of the thing I'm just compiling them. Okay. I have compiled most of the things.
No, no
So if you
issues.
give
Yeah,
some
go ahead. If I have
if you,
doubt, yeah,
yeah, yeah, so
definitely I
if
will
you have
ask
any
you.
doubt, let me know. Okay.
Sure.
So first of all, let me tell you why we have cut off this data. Is basically this data set will be used for our training purpose.
Mm.
This data set will be giving, we will be giving this to our machine learning model. Okay.
Mm-hmm.
And this
Mm.
data set, we will be hiding this from our machine learning model. We will not be giving this data set to our machine learning model. We will be giving
Mm.
this training data set, complete this whole, from this and this also output this target value also. And we will say that
Mm-hmm.
if the value is, if the features are similar to this, the output is this. Okay. And
Mm-hmm.
we have made
Mm.
a machine learning model. Okay. And now
Mm-hmm.
while doing the accuracy, while measuring the accuracy, what we will do is, now we will give this data once this model is ready. Okay. Now we will
Mm.
give this data only this much, we will not give this target value. Okay. So we will separate this target value again, and we will say
Mm.
predict it. Okay. Now predict it,
Mm-hmm.
this value, this 30% of our data,
Yeah.
we will give this to our machine learning model and we will say predict it. Okay. And then
Mm-hmm.
we will compare this predicted value with the original target value.
Okay. So you are comparing 30% result with 70%.
Not so using this
Now, or
70% I have used for training purpose,
okay.
because data is
Mm.
required for the training as well. Okay. For the
Mm-hmm.
machine learning model.
You, so you are saying means
Hmm.
okay. Training means sample data. That's what you are saying.
Yeah, training is sample data.
Sample. Yeah. So the 30% is the, I mean, data, original data. That's what you are trying to say, or
Wait, let me reframe it again. So see, you have this complete original data, like whole 100%. Okay. So out of
yes.
this, we
Mm-hmm.
are dividing it into a, you have
70. Yeah.
100% your data, and we are
Mm-hmm.
dividing it into 70%. It will be your for your training,
Yeah.
and
Mm-hmm.
30% for your test.
Test. Okay. Yeah. Now
Test
that's right. Okay.
test means
Mm-hmm.
you will be just giving your inputs.
Okay. Gotcha.
You
Mm-hmm.
will be hiding your output, and based on this, whatever the output will be, it will predict some values.
Mm-hmm.
Predict, these are the predicted values,
Mm-hmm.
and these are the actual values. So what you will be
Okay.
doing is you will be comparing them,
Yeah. Mm-hmm. Yeah.
and
Now
you
I
will
got
see
you.
how, what is the accuracy, like is it 89% accurate or whatever. Like there are some other metrics like square mean error, or like you have some error techniques to find what is the error between them. So this is the
Okay.
basic
Gotcha.
intuition, that you got 100% of your data, like your sample data, you will break it
Mm-hmm.
into 70/30 or 20/80,
Mm-hmm.
whatever it is.
Mm-hmm.
And then you
Mm-hmm.
will give your 70% complete data for your training, like it is a complete
Okay.
data. You have your
Mm-hmm.
features, you have target value,
Mm-hmm.
and you will
Mm-hmm.
giving this to your machine learning model, saying that on the basis of this features, we are
Mm-hmm.
getting this value as a target, and now try
Target.
to find some pattern, like try to fit this on this algorithm.
Okay.
And once
Mm-hmm.
the model is trained, so you just
Mm-hmm.
now you just need to give the features to it. You will give features, it will try to
Mm-hmm.
predict your target value. Now you will
Okay.
not give your target value to it while testing. Now we are testing our data.
Mm-hmm. So what is the use here?
of,
So, but anyway,
yeah.
first 70% of the data we
Hmm.
got the accuracy, right? So, without giving the target value, we are trying to find out 30% data for test, right?
Yes.
So, if there is a difference, what we will do? But it's supposed to be the same, right?
Hmm.
We are doing the same thing for training and the test, but for the test, except we are not giving the last one,
Yes,
right? We are trying
we
to
are not
find out
giving
for
the
that.
target value,
Yeah.
so it will,
So,
yeah.
okay, my question is, if there is a difference between 70% target and whatever find out the 30% without giving the target, right? So
No.
if there is a difference, what is the issue or that is the correct one?
So you are saying basically that so because this 30% and 70% division is
Mm-hmm.
done at the starting point only. So whenever you
Yeah.
get this
Mm-hmm.
data, at this time
Mm-hmm.
only you will divide this data. You will separate this data and you will not
Yeah.
give this to a machine learning model.
Mm-hmm. Mm-hmm.
Okay. And now on
Uh,
this basis of this 70% data, you will be giving this to a machine learning model to train.
okay.
And now you have this
Oh,
30%.
okay. Okay. Now we are comparing with machine learning with this accuracy. Okay. Okay.
Yes, exactly.
Yeah. Now I got you. Okay.
Exactly. Now you have
Okay.
this
Yeah.
30%. Now you will
Mm-hmm.
feed this independent variable or your features to our machine learning model. Again, we are hiding this.
Yeah. Yeah.
Now
Now
we
I
will
got you.
tell to compare this predicted value that
Then
a
to
machine learning model
the
will give with this
yeah.
value. This
Yeah.
is
Yeah.
our
Now
actual
that.
value. Actual value,
Yeah.
and this is our predicted value. And then we'll see the
Yeah.
difference
Now.
between them. Okay. So,
Yeah.
this is a just an just or idea of how machine learning
Mm.
works, like how do we
For yeah.
give data and get
Mm-hmm.
a better accuracy or
Okay.
predict some better accuracy. Okay, so if our
Mm-hmm.
accuracy is not that good, like it gives some 60% or
Mm-hmm.
70%, so it is not that good.
Mm-hmm.
Okay, so we'll try to come back again here and we'll try to change
Mm-hmm.
algorithm, like we are using linear regression, so we'll change
Mm-hmm.
algorithm, like we can give a random forest, so it is just a name of another algorithm, so we will try to
Mm-hmm.
do with this. We will try to
Okay.
change our scaling method, we will try to change our encoding method, and we'll try
Mm-hmm.
to change some other feature selection base. Okay, and we'll try to
Mm-hmm.
change on our EDA techniques.
Okay.
Okay, so
Mm.
this is how we try to increase the accuracy of our model. So this is how
Smart.
this
Okay.
machine learning works.
Mm.
Okay,
Mm-hmm.
I think I have confused you. If you have any
No, no,
doubts.
no. Definitely, yeah. Yeah.
Okay.
As of now, I'm good. Yeah. Once I go through, maybe I will, if I get any doubt, definitely I will
Okay,
ask you.
so just I want to clear you, make you feel confident with it, like how this machine
Yeah.
learning actually works. And now I think
Mm-hmm.
we are good to go with our bivariate analysis. Okay, so this was a
Mm-hmm.
separate thing. Okay, so that we have
Mm-hmm.
seen. So now in bivariate analysis we are just seeing here exploring our data. Okay, so that was a machine learning part, that after this process is done, completed, then we will jump to that process. Okay, that training, test, and splitting data. Okay,
Mm-hmm.
so now here what we are doing is, here we are seeing the head of our data tips. Okay, so you may see that this kind of this data it is. Okay, so you may ignore this two thing, like it is a flights data. Okay, so it has also another data set, that is your flights. Okay,
Right.
so it gives the information about how many flights, like in air,
Mm-hmm.
1949, on the month of January, these many passengers traveled. Okay, using this flight. So it has some data of it. Okay, the Titanic data is the same as that we are seeing yesterday. Okay, and there is another data set like that is iris. This is the most common data set while using while we learn data science. Okay, so it has a sepal length, or you may ignore this for a while. Okay, so now let's try to do some numerical bivariate analysis with these scatter plots. Okay, so scatter plots are basically, we try to plot these points, data points, on a graph. Okay, So here we are using this total bill
Mm.
itself, okay, this data set.
Mm.
Okay, so it have like here
Mhm.
we are giving tips, we are giving this column, total bill column, we are giving a tip column, and we are giving a gender column, smoker. We are giving these basically five column to our data, okay. And now what we are seeing is, we will see on the basis of this gender or the size, how many size the people came in on the restaurant, and smoker, if the person is a smoker, yes or no, okay.
Mm.
And then we will see, try to
Hey,
see.
hey, your
Yeah,
voice is flickering. Yeah,
okay,
last.
yeah, your voice is also, I
Yes.
think, yeah, I think I have some internet issues.
Uh,
Now is
Scatter
it,
plot.
now is it
Yeah.
clear?
Yes. Now it's clear. Yeah.
Okay, so in scatter plot
Mm.
what we do is basically we try to point plot are these data points on a graph, okay. Like here we are plotting our
Mm.
this total bill data, the restaurant bill data, and we are using total bill and tip, okay. So on your x-axis we have total bill, okay. So this is a total bill column
Mhm.
on your
Mm.
x-axis. On your y-axis you have a tips,
Mm.
okay. So it will the total bill is ranging from, is it the voice flickering
Mhm.
again?
No, now it's good.
Okay, so the total bill ranges from 0 to 50, around $50, and your tip is ranging from 0 to $10, okay. So here the data is plotted. So if you may see, if the total bill is increasing, like if a bill is around $50, your tip is high. If a person is having a bill of with a total with a higher amount, so the tip he is giving is higher. And for the person with a total bill less, okay, right, so he is giving a less amount of tip. Is this fine? Clear?
Yeah.
Do it make
Yeah.
sense?
So,
Right.
mhm. So,
And now also we are trying to see if these values, this gender or sex or smoker or size, do they really mm, matter, how they are involved in this tip, okay. So from this cross sign you may see that is the person a smoker or not. If it is like a cross, so this person is a smoker, okay. And if
mhm.
it is in a round, it is not a smoker. Like all the values which are in round, you may see round
Right.
values, so those are
Mm.
non-smokers.
Mhm.
And you have sizes also, like some dots are smaller than others, right,
Mhm.
and some are bigger, like this
Yeah.
dot is bigger
So
than
number of
another
people,
one.
more number of
Yes,
people. Mhm.
yes. So it basically specifies that, okay. And you have a gender
Mhm.
as like blue for female, and wherever
Yellow
you see
for
orange, that is
yeah.
your male. So this much whole information is just stored inside this graph, okay, using your
Mm.
scatter plot. And this is for your numerical
Mhm.
variable, because these
Mm.
are the numerical
Only
things:
numerical.
total bill,
Mm.
tip, size, and your gender. So gender is basically your mm, gender is basically your, here we are specifying it as a categorical variable and using it as your 0 1, okay. So like if
Mm.
the number of these value will be higher, so we will be having problem in specifying it, okay. So that's why mostly
Okay.
the scatter plot is used with numerical values,
Mm.
numerical to numerical, okay. So this
Okay.
is a bit basically it is, okay. So here you see you don't get any much insights, but whenever you will be using it in a real world scenario, most probably from the next week or after this just EDA finishes, then we will be see a real world project, and you will see that all these graphs make sense, and we see some huge insights that we get from it. Okay, like here you may see that it is not getting like more informational, but
Correct.
once we get in real world, like try to do something out of this data set, try to get some insights from it, you will see that it actually makes sense. Okay, so these are the basically the techniques, like you use scatter plots to draw these kinds of graph. You use bar plot if you want to, suppose say here we are reading this Titanic data set, and we will be drawing a bar plot out of it. Okay, so it is your numerical to categorical variable. Okay, so here we are using passenger class, this is your numerical variable, and here we also using some uh, categorical variables. Okay, and we are using bar plot. Okay, so this bar plot comes inside this Seaborn library. Okay, so here we are using three variables: passenger class, age, and gender. Okay, so we are drawing a bar plot out of it. Okay, so here if you see that we have blue color, that will be your male, and for orange it is female. Okay, on the x-axis, first of all you have to specify the x-axis, and then you have to specify the y-axis. Okay, if you see
Okay.
on x-axis you have passenger class like 1 2 3. Okay, so first passenger class, on this data set the number of your passenger class with 1 is higher. Okay, yes. Okay, and second is lower than that, and third is the bottom. Okay, and on the y-axis you see there is a age, and you can also see that with the passenger class 1, as I think we have seen on a on a previous class also, that if the passenger class is a VIP or the first, right, so the age is pretty higher, age is 40 as compared to the people with the lower passenger class.
But,
So this might be some insights, right?
yeah. Easy to understand. Yeah.
Yeah. Okay, so means it makes some sense. Like if the person is having age higher, so he may afford to purchase a expensive ticket,
First class. Yep.
first class. Okay,
Correct.
so this kind of information can be retrieved using it. Okay, using this bar chart. So it is basically a numerical to categorical value plot. And now we can see also another diagram, that is your box plot. So basically bar chart is like this. Okay, on you have x-axis, you have y-axis, and you draw some you put out some information to it, and now you have a box plot. Box plot, basically whenever box plot comes in, you may think on your mind as an outlier, so we can basically identify outliers through this. So now here what we are using is, we are using gender, we are using age, we are using this survived, yes or no. Okay, yes or no, 0 for I think no, and 1 for orange, that will be your yes,
Yes.
survived. Okay, and on the x-axis we have our gender, male and female, and on the y-axis we have age. Okay,
Yeah.
so we will see if the particular age, gender, like survived or not. Like for male, most of the people with lower age have survived, if you see here, right? So this is your basically your, this box plot stands
Direct.
for who have survived, and this is for non-survival. So the people with lower age has survived more. I think I have said on the previous time opposite. Okay, so the people with
Yes.
less age have survived more, and you see also there is some outlier like 80. Okay, and the people with higher age have less survival rate for male, and this is exactly opposite for female, if you
Yeah.
see. Like the people with lower age, like the female with lower age
But
have not
survive.
survived, and the female with higher age have survived.
Yes. Mm.
Okay,
Mm.
so this is the insight that we got through this diagram. And we can use heat
Mm-hmm.
maps. Heat maps are basically very easy to find a relationship between them, like on the previous class also we used them. So basically you can use draw them using your Seaborn library, that is our heat map. Okay,
Mm.
inside this you have to use this pandas PD, and inside this pandas you have another library that your cross tabulation. Okay, cross tab,
Mm.
you specify it
Mm-hmm.
with cross tab. Okay, inside you have to pass how many variables or how many features you want to find
Mm-hmm.
correlation. Here we want to just
Mm.
find the correlation between two. Is the
Mm-hmm.
passenger class correlated with survived or not?
Mm.
So if we see, it is. Here you cannot see actually what it is going on, but on the previous session we have seen a heat map, right? Like the
Mm.
thing, like wait, if
I
I,
think we didn't see heat map.
no actually, wait, just a second. It was on pandas profiling, right?
Mm-hmm.
Yes. Okay, so the correlation, so this is your heat map. Okay,
Oh, okay. So correlation. Okay. I remember correlation. So how it works, but heat map. Okay.
hmm? So heat map and these are the same thing, like this and this is your same thing on the
Oh.
x-axis. Wait, I think here it might be some different. Actually I haven't, three survived, one with a zero. Okay, so it is like that, non-survival, these are the number of non-survival people
Mm.
and these are the
Mm-hmm.
survived
Mm.
people. Okay,
Okay.
so on the third class, passenger class,
Mm-hmm.
350 people have survived, not survived.
That way. Huh?
Zero is not survived. Okay, so the third
Yeah.
passenger class, 350 people have not survived. Okay, and
Mm-hmm.
on the third passenger class, 100 number of
People
people
survive.
have survived.
Mm.
If you see that, uh, out of it we can see that in the third passenger class, number of survived people is less, right? So
Mm.
if you are on a lower class, lower passenger class ticket, so the chances of your survival is less.
Mm.
And if you are on a passenger class with your higher first class passenger ticket, so your
Mm-hmm.
survival chance is more or equal, say,
E.
right? And for second class you have just equal,
Mm. See. Yeah.
but it is some risky if you travel with your third class, like, because the chances of not surviving is higher if any accident occur like
Mm.
this,
Mm-hmm.
and
Mm.
your survival chances are less, like 150.
Okay. Mm-hmm.
So I think because this is not we are not doing this for getting some insights, so
Mm-hmm.
you may just see how it is, how the code is working, and that's it. Okay, so on the further class
Okay.
when we do some projects, then it will make
Mm-hmm.
sense, and we'll see how it is related and how we get some insights and how we make changes according to that. Okay,
Mm.
and like this we have some other maps as well. I think
Mm-hmm.
you may go through them, and we will for now,
Yeah.
like you have
Mm-hmm.
pair plot, we have line plot. Okay,
Mm-hmm.
and that's okay, and you may go through them and see how they works. Okay, you may read some blogs, and for
Mm-hmm.
now what we will do is we will see a method that is your ordinal encoding. Okay, again I am using a pre-written code.
Mm.
Same thing here, we will be doing is using numpy
Mm-hmm.
for numerical
Mm-hmm.
calculation, pandas
Mm-hmm.
for data manipulation. We are reading our this data set customer underscore
Mm-hmm.
customer.csv. Okay, And what this dataset takes is, it basically gives you age, gender, review, education, purchased. Okay. Okay, so I will not explain you this code, how means this data set. I will just show you
Right.
how you can change
Mm.
the values. Like here we
Sure.
have we are having categorical variables, right? This pg, ug, and now we want
Mm.
to change them, and you having review like good, average, and now we will change them on our numerical variables.
Okay.
And this is the way of how you slice your data set.
Yeah. Like.
This is your it contains your five features.
Mm-hmm.
For now you can see them as features only, so because
You are
we don't have any
taking.
target value here. Okay,
Yeah.
so we have five features. If you use like this slicing method,
Yeah.
now we are saying here as two
So
colon. Okay,
list
so means
from, yeah.
yes, so if we
First
are
pick,
basically
yeah,
saying
it
0
comes from
1
third one.
2.
Mm. Yeah.
No,
Mm-hmm.
from not first, from first third one, we are saying from third to last.
Yeah, third. Yeah, yeah. Starting number is
Two.
third. That's what I
Yes.
meant.
Yeah.
Yeah.
Starting number
Mm.
is third to last. Okay.
Mm.
So because
Mm.
here we are not specifying it anything, so take a default as is last. Okay. So from
Okay.
third to it to last. Okay. So it will be stored in your DF. Now if you
Mm-hmm.
see df dot head, it is your review, education, purchase. So all are in your categorical variables. Okay. So now here we will use a library that is sklearn, and that is your scikit-learn.
Oh,
Okay, so inside your
okay.
scikit-learn you have a library module that is your pre-processing, and inside this pre-processing you have another class that is your ordinal encoder. Okay,
Very good. Okay.
and now if you see uh, okay, so we have our xtrain. Okay, what we are doing is here we have divided our data into the training set and testing set. Okay, so I think our code is missing here, like the dividing thing that will be in your this standard scale. Okay, so this is the, you may think ignore that for a while. So this is your code. Yeah, so this is your training test split, how it works, like the thing I explained you here. This splitting, we have a 100%
75.
70 30.
Okay. Mm-hmm.
So how this is done in this code is, you have a library that you sklearn, it helps you to split your data. Okay, so it have your train underscore test underscore split, so you have to use it. Okay, so what it will give is, it will return you four variables. Those will be xtrain, okay, and xtest. So what is
Mm-hmm.
xtrain and xtest? Xtrain and xtest are these. So you have this in your as a whole complete data set. You have divided it into suppose is 70 30. These are your target variable, target, these are your feature. Okay, so here you have your xtrain and xtest. So this is your x, features are your x. Okay, so xtrain, this is your train, this is your test. So xtrain, xtest, target is your y. Okay, so y train, y test. So your data will be divided into four parts: 1 2 3 4. Okay, so all this value will be, these all minor or subset of your data will be stored in this, like x underscore train, your x underscore train will be your this data 1. Okay, your this x underscore test will be your this data 2, this.
Yes.
Your
Yeah.
x y underscore train will be this, y underscore train 3. Your y underscore test will be your 4. Okay, this will be stored. So this, using this train underscore test underscore split, we will be doing that. So what it takes as an argument is your your value, your data set. Here we are dropping the purchased column, this purchased column. So here only we will be having two features. Okay, so these are some other arguments. So this is your test size. Okay, so here you specify at how many size you want your data to be split. Like here we are saying 0.3. That means you want your data to be divided into 70% and 30% data.
Okay.
0.3. If you say
Mm-hmm.
0.2, your data will be divided into 80% and
Mm-hmm.
20%.
Mm-hmm.
Okay, so this is here we specify that. Okay, and now if you see your xtrain shape, xtrain, okay, so that was xtrain. Okay, so this will be a 70% of your original data. The rows will be 70% of your data, and
Mm-hmm.
target and the column will be 1 minus. Okay, so actually we were having this 3, right? Here we were having 3 column.
Mm-hmm.
Now if you see we have 2 columns,
Oh, draft
because
purchase.
yeah, because yeah, dropped purchased. And one more thing here, uh, and earlier if you see there are I would have to run this code. Okay, wait, let me run it. Df dot shape.
Okay. You will do that.
Okay,
Mm-hmm.
now here we are having white train and white test.
Mm-hmm. Yeah.
Okay, so we were here at ordinal encoding. So so we have done that same thing. Okay, for x chain. Now
Mm-hmm.
for x chain we have two value columns. Okay,
Correct. Yeah.
and now using that, those were basically your rating and your college, that your education, right? Review and your
Mm-hmm.
uh,
Mm-hmm.
education. So we have categories like poor, average and good for rating. So we are
Mm-hmm.
specifying that wherever you see these values,
Yeah.
poor or average or good, so you have to replace them. Okay, so these are the basically categories. And for
Mm-hmm.
education we have school, UG and PG. So all the values basically you have to specify. Okay, we have a function that is ordinal encoder. Okay, so what we
Mm-hmm.
are doing here is, once this object is created, ordinal encoder, okay, so that
Mm-hmm.
is done in OE. Okay, object encoder, ordinal encoder. Okay, so now
Mm-hmm.
this OE object can be used, and now this is your class. Okay, so this is instance of your class, and it
Mm-hmm.
contains some methods that can, that one of them is fit. Okay, so
Mm-hmm.
now you can use them. So your ordinal encoder or OE has a function that is fit, and inside this you have to pass your data. So this is our data set.
Okay.
Okay, xtrain.
Yeah. Yeah. Mm-hmm.
And once you do it, it have transformed all the data, like it have taken all the categories for
Mm-hmm.
first variable
Mm-hmm.
from this poor, average, good, so all will be replaced. Okay, and for
Yeah.
second column it has taken a value like school, UG and PG, and all the values have been replaced.
Mm-hmm.
And here we are storing that in our xtrain after
Mm-hmm.
transforming it. Okay,
Mm-hmm.
and now if you see our xtrain, it looks something like this.
Okay. Mm-hmm.
Okay,
Mm-hmm.
so if you see we were having poor, poor is replaced with 0,
Mm-hmm.
and
Yeah.
1 1, 1 1 will be for your average, average, and good, here we have 3 times. So good will
Mm-hmm.
be like 3 times, 2 is your 3 times, and again we have 0,
Mm-hmm.
so it will be your poor. After good
Good.
you,
Yeah.
you again have your poor. Okay, similarly for this.
Mm-hmm.
Okay, so this is how
Yeah.
your ordinal encoding works. And yes, okay, and here you having standard scalar. Scalar is also basically a simpler thing. We perform it because it helps us to bring all the values on a similar scale. You see, if you see the age here, Have you got the concept of this ordinary encoder, right?
Yeah, yeah, I got that.
If I'm going a little bit faster, let me know, okay?
No, no, it's fine. Yeah,
Okay.
definitely I will.
Hmm.
Yeah, you
Because
can proceed.
actually we
Yeah.
have to complete all this in like very few days or few hours, so that's why I'm running this fast.
Sure, sure.
Okay. So in this standard scaler,
Mm-hmm.
what we do is basically, let me explain this to you for a few minutes. Like if you see that salary, okay, salary and age, if you compare this, you see the value is a huge difference. Like 15,000 is very much different from 26. Like the
Mm-hmm.
difference is huge.
Mm-hmm.
1 lakh 2,000 is very different from 60. Okay, so what we do in the standard scaler is we try to basically scale them to a one value. Okay, so you will be your input, your you will be giving this data set, and after scaling, okay, so once this technique is performed or completed, your all the values will be a similar scale. Like if it is from 0 to 1, the all the value will be from your 0 to 1, or this value will be from 0 to 1. It will range from 0
Mm-hmm.
to 1.
Mm-hmm.
Okay,
Mm-hmm.
so there will be not this much difference. Like this is ranging from 15,000 to 1 lakh 2,000. Okay,
Mm-hmm.
and your age is from 20, and just like most of the time it will be like going through 60, not above that.
Mm-hmm.
Okay, so we want our data to be in a simple same scale. Like if it is from -1 to +1,
Mm-hmm.
age should be also from -1 to +1. So this can be performed or done using this technique, that is your standard scaler. Okay, so
Mm-hmm.
after performing this, your data will look something like this. All the values are scaled. Like if you see, all the value are from some value, like from minus some value, like means they have pretty much same value, similar values, means they range on a similar value. Because this is
Yes.
all done is, and you can basically convert, this is a two way, you can convert from this to this, and after
Mm-hmm.
your performing model you can convert back to it. Okay, you can fit this value to again to this value. There is some mathematical calculation that is performed here in transform function, so that
Mm-hmm.
basically uh, converts any value to this, any value to your that should then that make you range from 0 to 1 or -1, around that. Okay, so you may read
Mm-hmm.
about it, how this standard scalar makes value from, but how this mathematics works basically today, if you
Okay.
get some time, like how
Yeah.
does on the back end this standard scalar works.
Mm-hmm.
Okay,
So, yeah, give me one sample scenario. Why do we need a standard scalar?
example, right?
Mm-hmm.
Suppose say here effect of your using your standard scalar. So if you see distribution, okay, so this is your distribution of your age. So this is how your age is distributed, right, before
Mm-hmm.
performing scaling. Like
Oh,
your
okay.
this many
This is
people.
original
Okay,
thing. Yeah.
so it ranges from
Mm-hmm.
10 to 70.
Mm-hmm. Mm-hmm.
So if you are not if we are human, so it is good to see this. Like we know that age rise from this value to this value. Okay, so for
Mm-hmm.
computers, it doesn't care. Computers don't know what like age is, or it will not ignore it. Okay, so it basically
Mm-hmm.
wants some values that are scaled, so that it may have some
Yeah.
reference.
Yeah. Yeah.
Okay,
That's true.
so
Yeah. If I
that
see
is,
this graph, it's easy to understand. Yeah. -3 to 3.
yes,
It's wide like 0, 10
yeah,
to 70. Now I
yes.
got it. Mm-hmm.
So the basic like this is now in a normal distribution, it has center at
Yes.
0.
Yeah. Okay.
So
It's easy to.
for this purpose, you have to scale your data. Like here you see your salary scaling, like from -25. I don't know why it is like -25,000 salary in minus, but you may
Mm-hmm.
see like this. Okay, so you are getting like
Yeah.
something like this. for
Mm-hmm.
75,000 like this. So
Mm,
after
yeah,
salary scaling, you have value like this. Your
yeah.
distribution is centered at 0, so it is clean.
Mm-hmm. Yeah, it's clean. Yeah, as you
Okay,
said,
so
correct.
basically
Mm-hmm.
you clean your data so that
Mm,
your computer may understand it properly.
sure.
Okay,
Mm-hmm.
so this is the basic reason for doing it.
Mm-hmm.
Have you got it? Or any
Yep.
doubt, confusion from today's class? I think I have at the starting I have made some complex because I
No, no.
want
Now
to,
I
yeah.
understand. Yeah, I think I'm good so far. Yeah,
Because I
I will
wanted to
go
explain
through
you
this.
some more concepts. That's why I cluttered them.
Yeah, yeah. That is fine.
Hope
Yeah,
that
that is fine.
didn't confuse you. Okay.
Mhm. No, no. I'm okay. Yeah.
Okay. So, uh,
Mm-hmm.
if you have any doubt, query, or feedback from today's class,
No, today I'm fine. Totally fine. Yeah, I will go through today's class and the last class as well. I will come a couple of doubts if I have it for tomorrow.
okay. And in tomorrow's class, we will be doing some stuff like uh, we'll see what we do tomorrow. Okay, so like we will be completing this EDA first, like exploratory
Mm-hmm.
data analysis, and then we
Mm-hmm.
will we will be doing like that real world projects. Okay, we will try to do a project that is will be a flight price prediction. Okay, so in that basically you
Mm-hmm.
have a data set and you have to try to predict what will be your price of your flight. Okay, using a machine learning model. Okay,
Mm-hmm. Sure.
we will try to
Mm-hmm.
see that.
Yeah.
So
Sure.
let's wind up for today's class.
Yeah. Sure. And you
Yeah.
are going to share those all those, right?
Yeah. I
Whatever
will
you
be
are done.
sharing
Yeah.
this in Jupyter notebook. Okay,
Sure.
you can go through it. Okay. Okay.
Yeah.
Thank you.
Okay. Okay. Yeah. Thank you. Thank you. See you
Okay.
tomorrow.
Okay.
Mm-hmm.
Bye.
Yeah. Thank you. Bye. Mm.